This is mathheals.com, where you can find more links to YouTube math videos and computer science. And I don't have my little tablet running. Good tablet running. Okay. This is the probability of a type 2 error and a power of a test. The first part of what I'm going to show you here is based upon proportion. And then the second part will be based upon mean. The current textbook we're using is based upon proportion, but a lot of stats books are based upon the mean. So you have to watch the appropriate one for your particular textbook. Okay. Now, probability of a type 2 error, power of a test. Type 1 error, this is rejecting the null hypothesis when null hypothesis is true. Alpha is the probability of a type 1 error. Now, type 2 error, this is what we're going to be finding here, and the power of the test. This is accepting a null hypothesis when null hypothesis is false. Now to review a little bit, remember how to determine your picture, your tails. If you got and ignore the p, you can have any symbol there. You could have mu if we're talking about the mean. If you got a not equal to on H1, it's two tails. Less than on H1, it's left tail. Greater than on H1, it's a right tail. Well, I'm not going to go through these steps. Let's dive right down to the problems. Steps will actually make a lot more sense if we're actually working a problem. Okay, first do this with the calculator, TI3, TI4, and then I'll go back and redo it by hand. Okay, so it says to test H naught, P is equal to 0.40. Versus H1, P is less than 0.40. Now I don't like this notation myself. If this is less than, I like this to be greater than or equal to, but this is what is currently used in this book. But these are opposites of each other, so I really do like them to be opposite. It gives you the same answer in case you're wondering. Simple random sample of n is equal to 200. So n is 200. And 90 successes are observed. So x is equal to 90. If the researcher decides to test this hypothesis that alpha is equal to 5%, compute the probability of making a type 2 error if the true population proportion is 0.38. Some books just actually ask you to compare this against another population proportion. This maybe doesn't say true, but it just says compare this against P1 is equal to this. What is the power of the test? Okay, so that's the information they give us. Yeah, let's go up here. And we're going to find the probability of a type 2 error and the power of the test using the T83 and 84. Now these ones are pretty bare bones. There is no claim. They just dive right in and give us H naught and H1. Not all problems do that. Some you have to take the claim and write down H naught and H1. And if you're not very good at that, then go back and look at your lessons on claims again. Draw the picture, determine tails. You don't necessarily have to draw the picture, but if you want to visually see it. Less than on H1 means we're going to have a left tail. So left tail. Okay. Now it says find ZA sub L and or ZA sub R. You'll have both for two tails and round to 3 decimal places. Well, we said we have a left tail, so we're going to find ZA sub L, our first one here. This is step 4. So ZA sub L. And it tells us to do an INV norm based upon alpha. Alpha was 5%. So ZA sub L, let's see what that's equal to. Okay. So do second vars. INV norm is our third one. Press enter on it. And we want 0.05. Enter. And we get negative 1.645. Now I say here, round to 3 decimal places. You'll find that this is going to be kind of hard to get it to match your answer in a book if they're doing it by hand. Sometimes they'll do 2, sometimes they'll do 3. If you actually take it out to more than that, if you take it up to 7 or 8 decimal places, your answer will be more accurate, actually. But we'll go with 3. But realize that your answer may not match the books exactly by doing that. Okay, so that's our ZA sub L. Step 5. We're going to find P hat sub L and or P hat sub R. You'll have both for 2 tails. And I say round to 3 decimal places again. Well, we got a left tail, so we're going with our first formula here. And I actually meant to change those. I wanted to put them all as plus. The book was putting minuses there, and I liked it, but I didn't like it. So I want those to be pluses. Okay. So left tail, we're going to use this top formula. So let me write it down. P hat sub L is equal to P naught plus ZA sub L times the square root of P naught times 1 minus P naught divided by N. Now it says P naught is a number from the claim or from H naught or H1 in decimal form. So P naught will be the 0.40 minus 1.645. The reason why I don't like pluses and minuses on these is because it's already decided when you do INV norm, or if you look it up in a table, it's already decided, so you don't need to worry about that. It's automatic. P naught we said was 0.40 times 1 minus excuse me, times 1 minus P naught, 1 minus 0.40. Got another one coming, I feel it. Okay, so let's see what this gives us. .40 minus 1.645 times second x squared 0.40 times beginning parentheses 1 minus 0.40 closing parentheses divided by 200. Enter. So we got 0. Let me double check my entry there. Times 0.40 times 1 minus. Okay, so we got 0.343. I spent a good amount of time coming up this PowerPoint this morning, and the major part of the time was that I wasn't rounding. Typically, you do not round in the middle of the problem, and I wasn't getting the same answer. It was driving me nuts. It was close, very close, but it wasn't the same answer. And it's like, well, why in the world is this not the same answer? I finally figured out what he was doing in the book. He was rounding the 3 decimal places here, so I put this here. Now, next edition, he might change his mind and not round. So keep an eye out for that. If you round to 3 decimal places and your answer is slightly off, don't round. Typically, in the middle of a problem, you don't round unless you're referring to z-scores, and then you want it to match the table from the book better. Anyway, that's our P hat sub L. Step 6. We got left tail again, so we're going to find Z sub L. And it's based upon this formula. So we got P hat sub L minus P over the square root of P times 1 minus P over N. So as you're going through working these problems, you just follow the steps, and it kind of guides you exactly what to do. This says P is a true population proportion in decimal form. So Z sub L, we said P hat sub L right here is 0.343 minus P, which up here we said the true population proportion was 0.38. So then we'll have the square root of 0.38 times 1 minus 0.38 divided by n, which is 200. You have to be careful when you plug this in your calculator. If you plug it in all at once, you have to put parentheses on top. Okay, so got beginning parentheses 0.343 minus 0.38, closing parentheses divided by second x squared 0.38 times beginning parentheses 1 minus 0.38, closing parentheses divided by 200. Why does that do enter twice? Okay, so 0.343 minus 0.38 divided by square root of that times that divided by 200. Okay, now we're going to take this 2 decimal places. So it'd be negative 1.08. Okay. And I'll put that up here. Round to 2 decimal places. The reason why we do z-scores to 2 decimal places, then it'll match our book closer. Step 7. Okay, for the left tail, it says we're going to do normal CDF. This gives us beta, which is our probability of a type 2 error. We're going to do normal CDF. And Z sub L, which is negative 1.08, comma, E99. So our probability of a type 2 error, let's see what that gives us. Second vars, we'll choose normal CDF, the second one. Negative 1.08, comma, second, comma, 99, enter. And assuming I typed everything in correctly there, we get 0.8599. And that's our probability of a type 2 error. Now the power of the test is 1 minus beta. That's step 8. Find power of the test. So I'm going to have 1 minus 0.8599. I'm not very good at decimals. Let me go plug that in the calculator. 1 minus 0.8599. And we get 0.1401. So this would be the probability of a type 2 error. This is our power of the test. Okay, that was with the calculator. Let's redo it by hand. So let me write down the information they give us. They give us H naught is P is equal to 0.40. H1 is P is less than 0.40. N's 200. X is 90. Alpha is 0.05. And P is equal to 0.38. Okay. Let's see, that's calculator by hand. Okay. Write down the claim. Did that. Write down null and well, there was no claim. Sorry. Write down null and alternate hypothesis. We did that. I mean, draw the picture. Well, it's still a left tail. Less than on H1 is always a left tail. Step 4. It says find ZA sub L and or ZA sub R. You have to use both for two tails, and we'll use a standard normal distribution table. For a left tail, ZA sub L, it says look up alpha. Okay. Well, alpha is 5%. So come over here, and we're looking up 0.05. 0.05. 0.05. Here's 0.0495. Here's 0.0505. So if I come over here, that gives me my first part, negative 1.6. And it's halfway in between these two values. So I come up here, and this is 0.04, and this is 0.05. So it's halfway in between those, so I'm going to use 4 or 5. Now, if it's halfway in between, you do that. You take it to 3 decimal places. If it's not halfway in between, then you take it to whichever one it's closest to. So that's why I said the book we'll use, if you're using tables, sometimes it'll be 3 decimal places, sometimes 2. Okay, step 5. So then with the left tail, it's pretty much the exact, well, it is the exact same formula. So we're going to have P hat sub L is equal to P naught plus ZA sub L, square root of P naught times 1 minus P naught divided by N. And P naught is 0.40, number off of our claim. And remember how I said this sign takes care of itself. It's negative again, isn't it? So negative 1.645 square root of 0.40 times 1 minus 0.40 divided by N, which is 200. And yet again, we get 0.343, rounding to 3 decimal places. And again, this tells you P naught is number from the claim. It says round to 3 decimal places. Step 6. For left tail, we're going to find Z sub L. And it is exactly the same formula. So I got Z sub L is equal to P hat sub L minus P over the square root of P times 1 minus P divided by N. And so we're going to have 0.343 minus 0.38 divided by square root of 0.38 times 1 minus 0.38 divided by 200. So Z sub L is equal to negative 1.08 again. And again, we take it to 2 decimal places. P is a true population proportion, so forth. Okay, 7th step. Going to find beta. It says for the left tail, beta is going to equal to 1 minus the value from the table based upon Z sub L. And it says find the probability of a type 2 error. Look up the Z scores in the standard normal distribution table. Well, our z-score here is negative 1.08. So let's go look this up. Actually, what did we say? Left tail is 1 minus, so let me go put the 1 minus there. And then we're going to go look up negative 1.08 in our table. Well, negative 1.0 is here, and then our hundredths is across the top. And I'll make that a little smaller so I can actually see it. Okay, negative 1.0. And then hundredths is 8. So I come down here. Where they intersect is 0.1401. So 0.1401. which gives us 1 minus 0.1401, 0.8599. Well, that's weird. I didn't think they'd be exactly the same. I figured normal CDF would give us a different answer, but oh well. I don't think it'll always give you the same, so don't think that. And then step 8 is still the same. Find the power of the test, 1 minus beta. So 1 minus beta. So we got 1 minus 0.8599, which gives us 0.1401. Let me save that, and we'll look at another problem. So ES power of the test, page 01.pdf. Trying to think if I should name it something different. I guess it doesn't really matter what it's named. Okay, let's look at our second example. So we come down here and find it. So I'm down too far. There's our second example. And again, first I'll do it on the calculator, and then I'll do it by hand using tables. It says to test H naught, P is equal to 0.30 versus H1, P is not equal to 0.30. Simple random sample of n is equal to 500. It's obtained. 170 successes are observed. We're not actually doing the claim part, so some of this we're not using. If the researcher decides to test this hypothesis that alpha is equal to 0.01, level significance, compute the probability of making a type 2 error if the true population proportion is 0.34. So P is equal to 0.34. What is the power of the test? So, okay. Let's go up and find our steps for doing it on the calculator. There we go. Step 1 is write down the claim. Well, they jump ahead. They go ahead and give us the null and ultimate hypothesis, which is step 2. Step 3, draw the picture. Well, not equal to on H1 means we got two tails. Drawing a picture really doesn't benefit us any. It's kind of a visual thing. We just need to know two tails. Okay, so for two tails, it tells us we need to find ZA sub L and ZA sub R. Well, ZA sub L is going to equal to INV norm of alpha divided by 2. Alpha was 1%, divided by 2. And ZA sub R is going to equal to INV norm of 1 minus alpha divided by 2. It's 1 minus 0.01 divided by 2. Okay, so second vars, INV norm, 0.01 divided by 2, negative 2.58. Wait a minute, I said 3 decimal places, didn't I? Okay, scratch that. Negative 2.576. That's really hard for me to do because I'm pretty sure the table used two decimal places in this one. But, oh well. Now this next one. We got INV norm, so second vars. Choose the third one. And we got 1 minus 0.01 divided by 2. And we got a positive version of the same one. So this is 2.576. Okay, step 5. For two tails, we're going to find P hat sub L and P hat sub R. Well, P hat sub L is P naught plus ZA sub L times P naught times 1 minus P naught divided by N. Well, P naught is a number off of our claim. Yeah, number from the claim, which is 0.30. Sorry, I drew a blank. And ZA sub L is negative 2.576. Square root of P naught, which is 0.30 times 1 minus 0.30, divided by N, which is 500. Okay, so we get 0.30 minus 2.576 times square roots 0.30 times beginning parentheses 1 minus 0.30 closing parentheses divided by 500. Enter. And what did I say? 3 decimal places? So P hat sub L is going to be 0.247. Like that. Let me check myself. Minus 2 point times that, divided by 500. Okay, that looks good. Well, now let's find P hat sub R, which should be very similar. You see how we got P hat sub R is the same except for Z, it's ZA sub R. So we got plus ZA sub R times P naught times 1 minus P naught divided by N. So we're going to have P naught, which is 0.30 plus 2.576, because that's what ZA sub R is. It was a positive 2.576, times the square root of 0.30 times 1 minus 0.30 divided by 500. So if I come over here, I do 0.30 plus 2.576 times second x squared, square root, 0.30 times, beginning parentheses 1 minus 0.30, closing parentheses, divide by 500. And let me double check that. Okay, the 3 decimal places would be 0.353. 0.353. Okay. Step 6. For two tails, we're going to find Z sub L and Z sub R. So Z sub L is going to equal to P hat sub L minus P divided by the square root of P times 1 minus P divided by N. Okay, so this will be P hat sub L, which is 0.353 minus P, which P we said was 0.34. Divided by square root of 0.34 times 1 minus 0.34 divided by N, which was 500. Okay, let's see what that's equal to. Again, trick to this is when you plug in your calculator, put parentheses around top, parentheses around the bottom, or not around the bottom. 0.353 minus 0.34 divided by. The reason why is the bottom part, even though there's more than a single number down there, it's all enclosed within the square root. And then we've got 0.34 times, beginning parentheses, 1 minus 0.34, closing parentheses, divided by something, 500. Enter. And 2 decimal places, if I remember right. Because the tables in the back of the book are restricted to 2 decimal places if we were doing it by hand. And I'm just double checking my numbers. Okay, now let's find z sub r. Z sub r is very close to this. Z sub r is equal to the same formula except for it's p hat sub r. So this is p hat sub r minus p over the square root of p times 1 minus p over n. So that gives us what does it give us? Well, I screwed this one up. But I caught it. That's good. Let me put that in red so you can really see it. Piece my eyes crossed. This is 0.247. This one down here is our p hat sub r. Very disappointed you didn't actually point that out to me while I was recording this. Okay, poor sense of humor. Minus 0.34. I did that just to check to see if you were paying attention. 0.34 times 1 minus 0.34. I'm not even tired or anything either. Okay. Well, I know what this one's going to be. This is going to be 0.61. That's what we got up there. Okay, so let's correct this now and see what this is going to equal to. So, 0.247. 0.247 minus 0.34. Closing parentheses divided by second x squared, 0.34 times beginning parentheses 1 minus 0.34. Closing parentheses divided by 500. And we get negative 4.39. Okay, now let me double check that. Go back and double check my formula and make sure I plugged everything in the correct place. Go back and do that also. P hat sub L, 0.247. P hat sub R, 0.353. Okay, that's in the correct place now. Minus P, we said it was 0.34. So these aren't necessarily difficult problems, just lots of steps. Grab a drink here. For two tails, it tells us beta is equal to normal CDF. Z sub L, which is negative 4.39, comma, Z sub R, which is 0.61. Guess I should have wrote down the formula first. Not that it matters, but Z sub L, comma, Z sub R. So that's going to be normal CDF. Negative 4.39 and 0.61. Second vars, normal CDF. Negative 4.39, comma, 0.61. Enter. And we get 4 decimal places. I probably didn't put that on there, but typically that's what they do. 0.7291. 7291 would be beta. Okay, power of the test. That's equal to 1 minus beta. So we're going to have 1 minus 0.7291. So 1 minus 0.7291. There we go, 0.2709. Okay, let's go back and do this one by hand. So this first part is the same. I'll go ahead and write it down. And his two tails. There we go. So N is 500, X we don't use, but I'll go ahead and write it down anyway, is 170. Alpha is 0.01. And P is equal to 0.34. Okay, step 4. Let's see, where am I at? Right here, by hand. So we drew the picture, we did all the first ones. Step 4, find ZA sub R and ZA sub L, both of those. For two tails, let's do ZA sub L first. It says look up alpha divided by 2. Well, alpha is 0.01. Divide that by 2, and that's 0.005. So let's go look up 0.005 in our table. And looks like it's halfway in between 0.0051 and 0.0049. So I come over here, my first part is negative 2.5. Maybe I was wrong. Maybe they would take that 3 decimal places. 0.051 and 0.049, so halfway in between these. So I come up here, these are my hundredths place. 0.07 and 0.08, so I'm going to use 0.075. So I'll put 75 there. Aha! That's slightly different, isn't it? Assuming if I rounded correctly there. I'm going to double check that, just because I'm curious now. I won't redo that calculator one, but if I did an INV norm, 0.01 divided by 2, yeah, sure enough, 576. So in the table, let me double check that. Halfway in between this one and this one, 0.075. Yeah, sure enough. Okay, well, right away it's different. Well, let's find ZA sub R. And that says look up 1 minus alpha divided by 2. Well, alpha divided by 2 was 0.005. So I'm going to look up 0.995. So 0.995. Okay, 0.9949, 0.9951. It's halfway in between these. So I go over here, it's 2.5, and if I go up, it's again between 0.07 and 0.08. Which I know already is going to give us the 2.575. That's the way Two Tails works on proportion and mean problems. Doesn't work on chi-square that way. Okay. Step 5. Oh, I didn't change these, did I? I want them all to be pluses. Because again, the sign's handled automatically when you use INV norm or when you use the tables. So you don't need to have those incorrect there. Okay. Two tails. We're going to find P hat sub L. So P hat sub L is going to equal to P naught plus ZA sub L times the square root of P naught times 1 minus P naught divided by N. P naught is a number off of our claim, which is 0.30. plus ZA sub L, which is negative 2.575, square root of 0.30 times 1 minus 0.30, divided by N, which is 500. So P hat sub L, 0.30 minus 2.575 times square root of 0.30 times beginning parentheses 1 minus 0.30 closing parentheses divided by 500. And if I remember right, these were 3 decimal places, so this would be 0.247. Yeah, that's interesting. Came out the same, didn't it? At least for that one. Okay, now let's find P hat sub R. And it's this formula here. So we got P naught plus ZA sub R times square root of P naught times 1 minus P naught divided by N. So P hat sub R, P naught is 0.30 again, plus 2.575 times square root of P naught, which is 0.30 times 1 minus 0.30 divided by N, which was 500. Okay, so let's see what this gives us. 0.30 plus 2.575 times square root, so second x squared, 0.30 times beginning parentheses 1 minus 0.30 closing parentheses divided by 500. Enter. And let me double check all those numbers. And we get 0.353, which lines us up again because it matches over there. That'll actually make the next step a little bit easier. I won't have to actually plug it in the calculator because it's the same. Okay, so for two tails, we're going to find both Z sub L and Z sub R. So Z sub L is equal to P hat sub L minus P divided by the square root of P times 1 minus P over N, which we said P hat sub L was 0.247 minus P, which is 0.34, over the square root of 0.34 times 1 minus 0.34 divided by the square root of 500, which gives us the two decimal places, negative 4.39. Okay, and Z sub R. Same as the one on the left side there, but I'll write it down again. It's P hat sub R minus P over square root of P times 1 minus P divided by N. So that's going to be 0.353 minus 0.34 divided by the square root of all this. Which gives us 0.61. Okay. Grab another drink here. It says find the probability of a type 2 error. Look up the z-scores in the standard normal distribution table. So we got Z sub L is equal to negative 4.39 and Z sub R is equal to 0.61. Let's look these up. Negative 4.39. Looks like our smallest one is negative 3.4.09. I don't know much about it except for it's less than or equal to 0.002. Since that's my smallest one in that table, I'm going to use 0.0030 and a 2. Now, the other one is 0.61. So 0.6, come here, and then the 1 is in the hundredths place. So I come over to 1 in the hundredths place right here, where they intersect. What did I say, 0.61? Yeah. Would be 0.7291. I bet this will be off a little bit. Okay. Now this says for two tails, beta is equal to the value from the table based upon z sub r, which is this one, 0.7291, minus the value from the table based upon z sub l. Z sub l was this, which gives us, I think I can do this one in my head, maybe 72. Not very good with decimals. Assuming I didn't do that wrong. 0.7289. Well, that's not quite the same, is it? It's close. But when you think about it, 0.7291, 72.91%, 72.89%, those are the one and the same, aren't they? And then our power of the test is equal to 1 minus beta, which is 1 minus 0.7289. It's 1 minus 0.7289. And we get 0.2711. 0.2711. Okay. Let me save that. And then we'll look at the mean. So if you've been waiting for the mean, we're there. Those are finding the probability of a type 2 error and the power of a test based upon the proportion, like a proportion claim. Now this next example, we'll do it based upon the mean. So let's come down to here and write our problem down. Okay, it says test H naught, mu equals 400 versus mu is less, or mu, boy, I'm not doing so good here. Reading. Mu is greater than 400. A simple random sample of n is equals 100 is obtained. Assume the population standard deviation is 80. So sigma is 80. I made these numbers up. If the researcher decides to test this hypothesis at alpha is equal to 0.05. So alpha is equal to 0.05. Computer probability of making a type 2 error if the true population mean is 420. So it's telling us mu is 420. Now some books describe this differently. And also it says what is the power of the test. I don't got it open right now, but some books say compare this against mu sub 1 is equal to 420. But anyway, they'll give you another mu besides what's in your claim. Okay. Now let's go through our steps. First I'll do it on the calculator. So let me come up here. Well, this one's a pretty simplified version. There is no claim. If we've already written down a null and alternate hypothesis, they give it to us. Do our picture. Well, greater than means right tail. So dealing with the right tail. Okay. Right tail says find ZA sub R. So ZA sub R is equal to INV norm of 1 minus alpha. So we're going to do INV norm of 1 minus 0.05. So do second vars, choose INV norm, 1 minus 0.05, enter. And I'll take this to 3 decimal places, I think is what I wrote down there, 1.645. And that's our ZA sub R. Okay. Step 5. We're dealing with the right tail, so we're going to find X bar sub R, X bar sub R. Say that 5 times real fast. X bar sub R is equal to mu naught plus ZA sub R times sigma divided by the square root of n. So X bar sub R is equal to mu naught, number off of our claim, which is 400. ZA sub R is 1.645 times sigma, which was 80, divided by the square root of n, which is that. So X bar sub R is equal to 400 plus 1.645 times 80 divided by the square root of 100, which we know is just 10, but I want to show actually plugging it in. And that gives us 413.16. Step 6. We're dealing with the right tail, so we're going to find Z sub R. And that says X bar sub R minus mu over sigma divided by a square root of n. Well, X bar sub R was 413.16 minus mu. They told us to compare that against 420. And then sigma, what am I going down there for? Sigma was 80 divided by the square root of 100. Now we know one square root of 100 is a 10, and 80 divided by 10 is 8, but let's pretend we didn't. The key to plugging this in your calculator is put parentheses around the top, parentheses around the bottom. So I'll do beginning parentheses 413.16 minus 420, closing parentheses divided by beginning parentheses 80 divided by second x squared for the square root 100. And you don't have to put closing parentheses at the very end if you don't want. And that's only at the very end. So let me double check how I entered that. That looks good. Okay, so what did I say? 2 decimal places? Negative 0.86. Round to 2 decimal places, yeah. Okay, step 7. For a right tail, it says beta, which is our probability of a type 2 error, is going to equal to normal CDF negative E99 comma Z sub R, which is negative 0.86. Okay, so normal CDF, I'll do second vars. Normal CDF is our second one. Negative, you get E by doing second comma, 99, comma, negative 0.86, enter. And we get 0.1949. Now in this, in elementary stats, we usually just find this. We don't do much analysis on it and so forth. That's more for later on, at least at our college. Now, find the power of the test. Power of the test is 1 minus beta. So we've got 1 minus 0.1949. So 1 minus 0.1949. That gives us 0.8051. So that's our probability of a type 2 error, and this is our power of the test. Okay, let's go back and do it by hand. Okay, so we got mu is equal to 400. H1 is mu is greater than 400. N is equal to 100. Sigma is equal to 80. Alpha is equal to 0.05. And mu is equal to 420. And it's a right tail. Okay. By hand. Step 1, write down the claim. That's if you've given the entire thing. They've already scaled this down. Write down null and alternate hypothesis. That's given. Step 3, draw the picture. We did that. Same as the other one. Step 4, find ZA sub L and or ZA sub R. You will have both for two tails. Use the standard normal distribution table. For ZA sub R, they say look up 1 minus alpha. Well, alpha is 0.05. 1 minus that is 95%, 0.95. So let's go look up 0.95 in our table. 0.95. 0.95. Here's 0.9495. Here's 0.9505. Halfway in between that. So come over here. It's 1.6. And 0.95. Boy, my eyes get off. Here it is. It's between these two. So come up here. It's between 0.04 and 0.05. So this will be 4 or 5. Well, that works out nice. That's exactly the same as the other one over here. So we got x bar sub r is equal to mu naught plus ZA sub r times sigma divided by square root of n. I didn't change that, I guess, but it's the same slide, same formulas. So x bar sub r is equal to 400 plus 1.645 times 80 divided by square root of 100, which gives us x bar sub r is equal to 413.16. Okay. Those are all pluses, good. Okay. Now, right tail. X bar sub r minus mu. It's the same formula. So we're going to find z sub r, which is x bar sub r minus mu over sigma divided by square root of n. So we got z sub r is equal to 413.16 minus mu, which was 420, divided by, and I put parentheses on the bottom part again. Remember, that's important for plugging in your calculator. And we're going to get z sub r is equal to negative 0.86. Step 7. For right tail, it says beta is the value from the table based upon z sub r. Okay. Z sub r is negative 0.86. Let's go look it up in our table. Here's negative 0.8. Make that a little bit smaller. Hopefully you can still see it. Okay, the very bottom row here is negative 0.8. And then our hundredths place is a 6, so I come over to the column for 0.06, come down there, and it says 0.1949. So 0.1949. Oh, wow. That matches exactly. I didn't expect that. Power of the test. That's still 1 minus beta. That hasn't changed. So that's 1 minus 0.1949, which gives us 0.8051. So that's the power of the test, and that's a probability of a type 2 error. So let me save that. And we'll stop the recorders here in a minute. But again, let me recap what I've done. I've shown you how to find the probability of a type 2 error and power of the test based upon a claim that's dealing with proportion. Again, not every book does this. Some do proportion, some do mean. And then I ended this by coming down here and doing the probability of a type 2 error and power of a test based upon a claim based upon the mean. Now, I didn't do one based upon standard deviation. Hopefully there isn't a book out there that does it based upon standard deviation, but this at least covers probably most of them, if I had to guess. Let me go ahead and stop the recorders here.